Welcome to this video presentation. My name is Daniel Lange and I'm pleased to introduce High Five to you, an immersion-preserving attention guidance technique in virtual reality, which was developed by my co-authors Tim Claudio Stratmann, Uwe Grünefeld, Professor Susanne Boll and me. With recent advances such as improved tracking, higher screen resolutions and wider fields of view, VR technology has become increasingly immersive. Due to the freedoms that the user has in a VR world, the problem that the user might miss relevant content that is presented to him increases. To solve this problem, many creative and interesting techniques like content highlighting, perspective and saliency changes have been developed. However, these techniques have one major disadvantage. They change the perception of the user or the environment in an unnatural way and can therefore have a negative influence on the immersion feeling. With High Five, we propose a technique based on a form of attention guidance, which is common in film and theater, diegetic cues. These are visual or acoustic cues that are part of the presented world. Our goal was to seamlessly integrate directional cues into a VR environment without losing immersiveness. This gave us the idea to use a visualization based on swarm motion. In the first study, we compared biological motion from a pre-recorded swarm with non-biological motion from an algorithm, assuming that there is a difference in perception. We conducted the study with 20 participants equipped with an HTC Vive and an eye tracker. We measured the time to first fixation of the swarm in two different environments. We found evidence that humans can distinguish between these motion types and that non-biological swarm motion results in significantly faster response times. Furthermore, it seems that the quality of perceptions of non-biological motion seems to deteriorate when additional non-biological motion takes place in an environment. So in the second study, we compared High Five using the non-biological motion to 4 other techniques: arrow, blurring, dead eye, and subtle gaze direction. Again, we conducted the study with 20 participants equipped with an HTC Vive and an eye tracker. The study consisted of a search task that took place in the virtual forest setting from the first study, and the participants had to find a target apple in that apple tree, which could only be found with the help of the respective technique. So the results showed that High Five was perceived significantly faster than blurring, dead eye, and SGD. In addition, a pre-sense questionnaire showed that High Five had the least negative effect on immersion. So we can conclude that High Five results in fast response times and has the smallest negative effect on perceived immersion. Our results suggests that humans immersed into VR can distinguish between biological and non-biological motion. Interesting is that the quality of perceptions of non-biological motion seems to deteriorate when additional non-biological motion takes place in an environment. Thank you for watching.